So now we're going to move on and we're going to talk about variable length subnet masks. Now, variable length subnet masks, or VLSM, is used in large enterprise networks to more efficiently use the available address space. And VLSM has a very specific definition. Essentially, VLSM is defined as using two or more different subnet masks within the same classful network. Now, if you're ever wondering if you're using VLSM, you can just do a show IP route on any router in your network, and it'll be very helpful and tell you this network is variably subnetted, and you'll see it when we get into the labs here in just a little bit. So if, for example, you're using the Class A network 10.0.0/8, and you've broken it down into some Class C networks and some /30 networks for your WAN connections, you're using VLSM because you have two different network masks within the same classful network up here. However, if you have two different networks and use different subnet masks between those networks, you're not using VLSM. Let's say, for example, you're using the 10 dot address space, but you're using all Class C networks for all of your branch locations. You've got 27 branches, and they all have a Class C that are carved out of 10.0.0.0, 10.0.10, 10.0.20, so on and so forth. Let's say for your WAN links, you're carving out a single Class C network, this 192.168.1.0, with that subnet mask, the /30, for your WAN connections. In this case, you are not using VLSM because you are using one subnet mask for this network and one subnet mask for this network. Now again, to go back to our previous example, if you were using both of these subnet masks within this same 10.0 network, then you would be using VLSM. So what's an example of a network that uses variable length subnet masks? Well, like with everything else, I have a diagram. Now you'll notice that all of the IP addresses on this little network diagram here are all in the 10 dot Class A network. However, you'll notice that each of the branches has a /24, or what's normally considered a Class C subnet mask, 10.1.1.10/24, 10.2.1, 10.2.2 over here. However, each of the WAN links between the routers all use a /30 subnet mask, so there's only two IP addresses on the link, one for each end of the link. This is variable length subnet masking because you have two different subnet masks within the same large IP network. Now, with anything that's too good to be true, there are some pitfalls of using VLSM. First off is obviously it requires careful planning on the part of the network engineer. You want to make sure that you use the right size networks in all the locations so you don't have to go in and add multiple small networks to a single location when a larger network, when a single larger network, would have worked just as well. If you're using VLSM, adding subnets at a later date can be kind of problematic if you've already used the next network in line for that location someplace else, and that really gets into route summarization, which we'll talk about elsewhere in the course. The biggest pitfall of VLSM, in my opinion, is that it is very easy to create network overlaps if you don't plan properly. These network overlaps cause network instability. And again, this goes back to the careful planning and adding subnets at a later date. They're all kind of tied together, if you will. Now, some of you that might be kind of new to networking might ask, well, what do you mean by network overlaps? Well, let's look at another diagram. I love my diagrams. Just wait till we get into the router labs and you see some of the labs that I've set up inside GNS3. At any rate, we have a small, simple network here, 172.20.2.1/23 over here, and the various other networks over here on the right-hand side. Now let's say that this location C is a new addition, so you've put this network out here, 172.25.1/24, out at that location, and when you do, you get reports from location B that, hey, I can't get to any of the IP addresses over here on section C. So you dig into the problem report and everything kind of looks good to you, so let's just walk through the troubleshooting here for this particular network layout. Now, if you're going to examine routing, the first thing you'll want to do is just lay out all of the networks as configured across your network. So location A has subnet 172.20.2.0/23. Its first address is 2.1. The last address is 3.254. There's the broadcast address. Location B has 20.4.0. Its first address is 4.1. Its last address is 5.254. There's the broadcast. Location C has 5. Wait a minute. These two locations overlap. That's what we mean by a network overlap. the same range of IP addresses are configured at both location C and location B. So what's actually happening is that hosts on network B think that these hosts down here that are on network C are on the local subnet. So it's just sending out ARP requests to the local subnet, to 5.5 or 5.7 or whatever address you're trying to get to, and nothing on this network is responding. Hosts from network A see this 5.1 network as being behind both routers B and router C. So any traffic from A is just getting load balanced across both of these links if it's going to the 5.1 network. So you as a network engineer have to go into location C and re-IP that entire location, which if it's a new location, it's not really a big deal. If someone's been there for quite a while and has got printers and firewalls and all these other nice things configured up, it can be kind of a pain in the backside. So that concludes our discussion of the joys and pain of variable length subnet masks.